Hey guys, welcome back to my video series on solving LeetCode problems, and now we're solving problem that is evaluate the reverse Polish notation, problem 150. So I actually recorded the video, but it was too long because I had like this weird bug, which I'll get to. But I had a submission, and the submission was actually pretty good. It was the first successful submission that I had. So let's get to it. Evaluate reverse Polish notation. So we're given a reverse Polish notation expression, and we want to output the number that it corresponds to, the value of the expression. So what is reverse Polish notation? Let's say you have 2 plus 3 divided by 5 times 5. So what's the result of this? Well, some people can say, well, these are some like internet memes, like, what is the right answer? Is it 2 plus 5 and then you divide by 5 and then you multiply by 5, or 2 plus 5 divided by 5 times 5, or 2 plus all of this together? Well, it's ambiguous, but you can have 2 plus 3 and then divide by 5 times 5. And you can also interpret as 2 plus 3 divided by 5 times 5. And that can also, well, let's just put some other parentheses here. So there's like many ways to interpret this. So a person that RPA, well, not this, reverse Polish notation, was invented by philosopher and computer scientist that's Australian called Charles Hamblin in the 1950s to facilitate memory storage of zero index. Okay, so he was Australian, so why is it called Polish? I'm actually curious. The reverse logistic position. Wow, who invented this? I just saw Charles Hamblin, so Charles. Maybe it was not Charles Hamblin. Precision Polish refers to the nationality of logician Jan, who invented Polish notation in 1924. Oh. The algorithm notation for this scheme were extended by Australian philosopher and computer scientist Charles L. Hamblin in the 50s. So I guess it was invented by Jan, and then it was also developed by Charles. So let's get to it. What is this? So Jan and then Charles, they came up with this. Let's write a non-ambiguous way of doing math. That's not so easy to read by humans, like for us, but for computers it's super easy. So let's say we want to do 2 plus 3 divided by 5 times 5. And this is our intention. This is what we want. So we need to do 2 plus 3. So we will represent that with 2, 3, and a plus. And then we also want to do 5 times 5. So 5 times. And then we want to divide all of them. So it's 2, 3, so divide this one with this one, so it's 2, 3 plus 5 times, and then division. So this is not so easy to read for humans, we're not used to this, but this is indubitable of what it means. So we know for a fact that this means this with a parentheses, and we don't need parentheses. That's the advantages. We don't need parentheses. Okay, so let's implement this. We need to implement something that reads this and outputs the result of this, which is 2 plus 3 is 5 divided by 25. So it's a decimal number, but okay. Let's do that. So how do we do it? We have a stack. And if you know, a stack is a last in, first out. Let me just make sure if I'm not saying anything crazy, last in, first out. It's a stack pile. I think the first in, first out is the queue. Yeah. Okay, thanks. And then our stack starts with nothing. So we go and, okay, we found something here. Is it a number? Yes, it is. We put it on the stack. Then we find another number. It's a number. Yeah, put it on the stack. Then we find an operator. Actually, it's plus. Okay, so let's remove it and let's replace the last two elements of the stack with that result. So 3 plus 2 is 5. So I'm just going to copy and paste this 5 to make it easy. So 5. Okay, next one. We get the 5, we put it on the stack. Then same thing. Same thing. We put it on the stack. And then the times. Okay, last two, 5 times 5, 25. Okay, and then you continue. Oh, an operator. Let's remove the last two here. And then it's 5 divided by 25, which is what we have here. So this is our algorithm. So let's get to implementing this. Let me use a simple example. So what do we do here? So we need to iterate for a token in tokens. But first of all, stack is going to be a list of integers that starts with 0. That starts with nothing. So for token in token, and what we say here, if token dot alphanumeric dot is numeric. What's going on? I'm not getting my autocomplete as I usually do. For token, oh yeah, I have the debugger on. So token is a string. So if token dot is or alphanumeric, what's going on? I'm not getting the is numeric. Okay, is numeric. Then stack dot append integer is converted to an integer of token. Else it's an operator. Operator is token, so we don't even need to do that. Let's go and say the left operand is, actually let's start with the right operand. Right operand is stack.pop, which will remove the last element. Pop removes the last element, default last, and puts it in right operand. Same thing for the left operand. And result, and we do stack.append result of the operation. But what is the result? If the token is a plus, then its result equals left operand plus right operand. And there's a bunch of ifs here, also actual elifs. So this one turns into minus, times with multiplication, and division. So here, there's an issue. So they want us to do integer divisions. As you can see here, 6 divided by minus this will be 0. So that will be integer division. But that's not it. We will have problems later on. Trust me. So we do that stack.append result, and we do that all the way, and then we return stack.pop. We should end with just one value in the stack which is the result that we're looking for. Okay, so let's just run this and let's see what we get. We get 9. Good. Now let's try this. 9 was correct. We should get a 6. Oh. Didn't copy it straight. Six. And now, last but not least, something that will probably give us some trouble. Okay, pop from an empty list. What's the issue here? The issue is that we have negative numbers. And when we're trying to convert a negative number to alphanumeric, we try to check if it is alphanumeric. It says no. It says my computer says no. Or, so we need to add the case of token's first character equals a negative sign and token, the rest of the token, is numeric. So now if we run this, we get 12, which is not what we want. We want 22. Why and why do you ask? And this is what caused me problems. So let me run this. So we're here at the division, and we need to divide 6 by minus 132, 132, and the result will be 0. If we do the integer division, it will be minus 1. But the funny thing, so 6 divided by minus 132 is minus 1. But if it's 6 divided by 132, it's 0. So this is not what I was expecting. So basically, if let's do just the division, and I want it to get closer to 0 if it's negative, and also closer to 0 if it's positive. However, if I do round, things will be strange. I need to do math.ceiling for this situation and math.floor here. So let me just check something. If result is less than 0, so if this is negative and if there's actually a remainder of the division, because we do get 0 if we do get the result we want if the numbers are positive, but if the numbers are negative, we need to do result plus equals 1 just to find this, just to go around this problem. So now our result is 22, which is what we want. Yeah, this math.floor was something I tried previously. So let's just submit this, see if it works, and it works. It did worse than before, but I think the code was pretty much the same. I can even look at it. Actually, it's right, it's the same thing. I wrote left operand. Should have written operand. Okay, now I have 94%. I'm happy with the results. I hope you guys enjoyed it. See you later.